إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا.
Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to another explosive, action-packed episode of the K-Way Mathematics program here on ITV. I'm your host Mohammed Kota from the K-Way Mathematics Institute here in Johannesburg, and I'll be presenting to you better ways, shortcuts, and dynamic techniques in order for you, the grade 11 or 12 learner, in order to pass your exams for 2015 here in South Africa. Right, let's get started. We ended up on our last calculus show, we ended up with the cubic function. I did promise you, yes, our last topic is optimization with volume and total surface area, but I did promise you that I'm going to explain to you what is the point of inflection. So let's go into the point of inflection a little bit before we actually get into optimization. So the point of inflection, generally the question will just ask, give the x point of the point of inflection. Now point of inflection, just to show you what the process is, point of inflection, this is the actual point on the graph, and generally they will just ask you for the x point or the x coordinate of the point of inflection of the graph. Okay, now point of inflection, guys, you all know, your teachers probably told you this already, this is the only time in calculus where you will be using second derivative. Other than that, you will continue using first derivative. The only time you will use second derivative is when you are trying to find out the x value of the point of inflection. The derivative of the derivative, that is called second derivative or the point of inflection. So if your original graph was f of x was equal to, in our previous episode, the example that we used was x cubed plus x squared minus 5x plus 3. We then found the first derivative, which was 3x squared plus 2x minus 5. If you still have your notes, right, go back to those notes and check. And now for the point of inflection, POI, point of inflection, the x value, we're now going to say f double dash x, second derivative, is equal to 3 times 2, 6x plus 2. We equate it to 0. Solve for x. 6x is equal to minus 2. X is equal to minus 2 over 6. X is equal to minus a third. Boys and girls, that is how you would find the x value of your point of inflection. Now, let me explain to you. Your teachers might have explained to you this concept already. What is the point of inflection? That is the actual point on the graph where the graph changes its direction from increasing to decreasing, from concave down to concave up, or concave up to concave down. That is it. Minus a third. Now, when you sketch a graph, I just wanted to show you, because sometimes to many of you this is not making sense at all. So you see a graph. If you remember what this graph looked like in our previous episode, the graph looked like that. The point of inflection would probably be somewhere there, minus a third and there. That's the point of inflection. Now you might ask, now what relevance does that point have on the graph? Why is that point the exact point in which the graph turns? Okay, let me explain to you something. We do know that 3x squared plus 2x minus 5, first derivative, is a parabola. The first derivative is a parabola. Now if you had to sketch this from your knowledge of functions, if you had to sketch the derivative, what would the derivative look like? The derivative would look something like, I'm just doing a rough sketch, would look like that. There we go, that is your derivative. So this is now not f of x, because f of x was your cubic, so this is f dash x. F dash x, you can sketch your derivative. So sometimes in the exam they will tell you, sketched is the derivative of the original. Find the derivative. I'll show you how to do that. But coming back to the point of inflection. So if this was the derivative, the graph is the derivative, and the x value is the turning point of your derivative. So there we go. That is the point. Okay, but obviously this graph is not drawn to scale. X is equal to minus a third. So basically this graph would probably look, just to show you, to draw it a little more accurately than that, graph would probably go like that. That's your x value of minus a third. Now that point there, that point is your point of inflection. Point of inflection. That is your point of inflection. It shows you exactly that the graph here is changing from decreasing to increasing. That is your point of inflection. This minus a third, because this is your derivative of your derivative. So f dash x was your original, and this point here is your f double dash x. So the point of inflection after sketching the graph will represent the derivative of the derivative, or the turning point of that parabola. Now, question that appeared in about two years ago in the final exam, right? And this knocked most of the grade 12s out. They gave you the derivative. They gave you the derivative as a graph. So all they did, I think this was November 2011 or November 2012. They gave you a graph like this. They told you that this point here was 2 and that was negative 1. And they told you that this was f dash x. And they told you that the question in the exam stated, it said, sketched, there's it, sketched is the derivative of f of x, of the original. Find the derivative. Question, answer. Now boys and girls, this is not a calculus question. This is a functions question. Why? This is a parabola. They tell you, they just sketched the derivative. They want the equation of the derivative. How do we get it? So it's absolutely easy. All we have to do is we say f dash x is equal to, we're given two x-intercepts, x minus x1, x minus x2. This is equal to x plus 1 into x minus 2, which is equal to x squared plus 1 minus 2 minus x minus 2. There we go. That is your derivative. The derivative is the equation. This equation here is this equation is the equation of your derivative. Okay? That's it. All right, let's now go on to optimization, and let's show you what optimization is all about. Now, optimization is they give you, you need to know all your formula, right? By now you are in grade 12 or 11, okay, grade 12. We now need to go to all your previous formula. You know your standard shapes, you know your square, your rectangle, your circle. Should we do it on show to brief you? Yeah, I think let's do that. Right. So we know that if we have a square, right, you've got, let's say, area, you've got perimeter, and you've got volume. Okay, so the area of a square, we all know area is length times breadth. I'm giving you all your formula here quickly. Right. The perimeter of a square. The perimeter of a area, perimeter, volume, guys. Area, perimeter, volume. Area of a square, length times breadth. Perimeter of a square is 4 times side. So perimeter is equal to 4 times side. Or you can say side plus side plus side plus side. The volume of a cube. The volume of a cube is going to be given by volume is equal to length times breadth times height. Okay, that's of a square. These are of your standard shapes. Now you've got of a rectangle. Right, the area of a rectangle, we all know area is equal to length times breadth. Perimeter, you can say side plus side plus side plus side, or you can say 2 times side plus 2 times side. So 2 times side plus 2 times side. Okay, then we've got a prism, rectangular prism, and there we know the volume of this is going to be length times breadth times height. Okay, now you've got a circle. The area of a circle we all know is pi r squared. Okay, area is equal to pi r squared. We all know pi, we're going to be using 3,14 in your exam. Okay, your perimeter is your, another word for perimeter is your circumference, and perimeter is equal to 2 pi r. And if you've got a cylinder like that, that being your radius, that being your height, your volume of this is going to be pi r squared times height. Okay, boys and girls, these are of your standard shape. We're going to cut for an ad break. When we get back from the ad break, I'm going to give you one more shape, which is your triangular prism, and then we are actually going to go into the application. Then we're going to do total surface area and the exact application of calculus in calculating the lengths or the sides, the areas, the perimeters, and the volumes of the various shapes. Boys and girls, enjoy your break. Stay tuned.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back to the K-Way Math Show. Before we cut for the break, we did all your formula on your normal shapes, your square, rectangle, circle. That's your cube, your prism, and your cylinder. We're now going to go on to the last one here, which I promise you, we know that this is a triangle, and to calculate the area of a triangle, area is equal to half base times perpendicular height. We all know that. The perimeter of a triangle is just side plus side plus side. Remember, perimeter is your distance around a shape. And then if you have a triangular prism, something that looks like your Toblerone box, right? You all eat Toblerone. I shouldn't be mentioning that on TV now, especially now in Ramadan. Right, here we go. We're now going to get your volume of this is going to be half base. You're going to take your area, half base times perpendicular height. That's in your one triangle. So say take a triangle like that. So if this being your base, it's going to be, let's call this triangle PQR, and let's call that H, small h. So volume of this would be half your base, QR, times your perpendicular height. They might give you a perpendicular height here in the triangle PQRS, times PS. So half your base times your height times your big height times H. And that would be the volume of your triangular prism. Okay, so boys and girls, I hope you know all of this. We're now going to go, that was your area, perimeter, volume. We're now going to go on to total surface area. Now total surface area means what is, it means exactly what it says. What is the total surface area? How much of paint is required? So if I took this duster, how much of paint is required in order to paint this eraser or this duster? That is called total surface area. What's the outside area? How much of material is required in order to manufacture this? That's called your total surface area. So now, we're now going to go on to total surface area, and I know you've got various formula for all your different shapes. Well, welcome to K-Way. We're going to give you one formula that you could use for all your shapes. Okay. So total surface area for closed top and bottom, meaning that the top and bottom is closed. Let's look at this glass. Let's look at this tumbler. Right. We have here total surface area is equal to, for a closed top and bottom, closed top and bottom, meaning that if this cylinder was closed on the top and closed at the bottom, we would use the formula total surface area is equal to 2 times area of base plus perimeter of the base times your height. Okay, so I'm just going to put it in brackets here. This is 2 times area of base plus the perimeter of the base times your height. Okay, now obviously, if this is a cylinder, if this is round, your area of base, because it's closed, we say two times. This glass here is open on the top. So common sense, will we say 2 times area of base? How many bases does it have? Only one. So we'll say 1 times area of base plus perimeter of the base times the height. If the top and bottom was open, so take a toilet roll holder, open on both ends. It's got no base, so common sense, can we say 2 times area of the base? No, you would just say perimeter of the base times your height. Now you would just adjust these formula for all your different shapes. If this was a cylinder, area of base would be pi r squared. Perimeter of base would be 2 pi r. If this was a cube, 2 times area of base would be 2 times length times breadth plus perimeter of the base in a cube 4 times side times your height. If this was a rectangular prism, 2 times length times breadth plus, in brackets you would say 2 times side plus 2 times side times your big height. Okay, so you can adjust this formula for all your different shapes. So total surface area 2 times area of base plus perimeter of the base times your height for closed top and bottom. If the top is open, you only got one base, 1 times area of the base, or just area of the base plus perimeter of the base times your height. If top and bottom is open, you would just say perimeter of your base times your height. You won't use the area of the base. Why? Because there's no base. Okay, let's now go into application. So, one of the examples that we give you in optimization. We're going to do about 3 or 4 examples. If you need more examples, you need more training, boys and girls, please purchase our set. Our set is very, very, very detailed. Send us emails, send us your questions. We want to know from you, the viewer, what are the questions that you need. We will then send you a response. If you feel like you would like to come onto the show, remember the floor is open. The show is not my show. The show is your show. We want you, the viewer, to put your input, to ensure that we pick up mathematics. Remember, we are now part of a mathematics revolution. This is so explosive. We want it to be so huge. We want every individual in this country to be part of the show. Okay, so we want your emails, we want your contacts, we want you guys to phone in, and we want you guys to be part of the studio. So the next time that we have the show, inshallah after Ramadan, we want to see 10 people here, all from different parts. We want Cape Town, Durban, Joburg, Polokwane, every area here, and we want everyone contributing to the show. So let's get started. Okay, we now go into a shape. Let's give you a shape. Let's take a cylinder, right? And I tell you that this here is x, and I tell you that the height is 300 minus x. I tell you that question number 1. Now generally this is the style in which your questions are going to be asked under calculus. This is the last part. It's worth 10 marks in your exam. So after you've done first principles, after you've done derivative, after you've done limit, after you've done finding the equation of a tangent at a point, after you've done the cubic function, now we get to optimization. So now the questions, they give you a shape and they say, show that the volume of the shape of the object is given by volume is equal to 942x squared minus 3,14x cubed. They're going to give you a hectic formula on that side. Okay, that's the first one. Show that the volume of that shape is given by that. Question number 2 in here, and that will be for about 3 or 4 marks. Let's call it 3 marks. Question number 2. Find x giving maximum or minimum volume. That will be another 4 marks. And the last one, find the maximum volume of the object. And that's another 3 marks. 4 and 3, 7, and 3 on the dot, 10 marks. Okay? Now, generally this is the style in which the questions will ask. Show that the area, show that the volume, show that the total surface area is given by a formula you've never seen before. Then they say, find x giving maximum or minimum, and then find the maximum or minimum volume or area or total surface area. Now, when we do this, I want you to pay attention. When we do question number 1, we use standard formula. Standard, let's write it, standard formula. When they say minimum or maximum, we know in calculus, whenever they talk about minimum or they talk about maximum, what are they talking about, guys? They're talking about derivative. That's where we're going to be using derivative. Find the maximum volume, that's where we're going to substitute. And this is the order, this is the style. That's how simple it is. Standard formula, derivative, and find the maximum volume. So let's answer the question. What do we know? Question number 1. Show that the volume is, what do we know about, forget about that. What do we know about the volume of a cylinder? Volume is equal to pi r squared times height. Yes or no? What is pi? We're going to be using pi as 3,14. What is r? R is x squared. What is your height? 300 minus x. Are there brackets here? No. Should we remove the brackets? Yes. So this is 3,14 times x squared is 3,14 x squared into 300 minus x. Now we multiply this 2 out. The volume is equal to 3,14 times 300 is 942 x squared minus 3,14 x squared times x is 3,14 x cubed. And there we go. We've showed that the volume is given by that expression for that specific shape. Okay? We found the volume. We now say find x giving minimum or maximum. What did I say? Minimum or maximum, what do we use? Derivative. So to answer question number 2, we take volume. Volume is equal to 942 x squared minus 3,14 x cubed. We're now going to be using derivative. So we're going to say dv over dx. We're finding the derivative in terms of x. Therefore, dv over dx. Now we're going to be using power rule. So don't ask me what I'm doing. We're using the power rule. Power times coefficient minus 1 from power. Power times coefficient minus 1 from power. So 2 times 942, 1884. 1884 x minus 3 times 3,14 is 9,42 x squared. What do we know for minimum or maximum? It's always equal to 0. Now we've got two values there equal to 0. It's quadratic. We now need to solve for x. So take out your highest common factor. What's your highest common factor here? 9,42. I'm taking out HCF. I'm taking out the highest common factor. I've got two terms equal to 0. So 942 x is my highest common factor. Now how do I find my other two factors? I take each term and I divide it by what I took out. So 1884 divided by 9,42 will give me 200 minus 9,42 x squared divided by 9,42 x will give me x. So I've got two factors equal to 0. I got 9,42 x equal to 0, or I got 200 minus x equal to 0. So now x is equal to 0, 0 divided by that is 0, or negative x will equal to negative 200, x is equal to 200. Okay, now in this case x, we know x can't equal to 0, therefore 200 is x giving maximum. In this case, therefore 200 is x giving maximum volume. Now, I need you to pay attention. Sometimes you will get this here as say 100 and that as 200. Let's say you get 100 and 200. Can we automatically assume that 200 is x giving maximum volume? That the higher x is really the x giving maximum volume? You'll have to check. You'll have to take each one of them, substitute it in the original. Because sometimes if I took 200 and I plugged it into here, I would get a negative volume. Can you ever have a negative volume of a shape? No. So therefore, the lower x, in those cases, in certain cases, your lower x will be x giving maximum volume. Why? Because it's giving you a positive volume. So you'll have to just do it by check. Trial and error in the exam. Take your lower one, plug it in, get a value. Take your higher one, plug it in, get a value. Check whichever one gives you your higher positive value. Remember, the higher positive value, the higher positive x value gets maximum. Higher positive x value gets your maximum. Now they say question number 3. So what did we do? We got question number 1. We did the derivative. We solved for x. Now they say find the maximum volume of the shape. So obviously we now found x. So the next most obvious thing to do is to plug that x back into original. So v is equal to 942 x squared minus 3,14 x cubed. So volume is equal to 942 into 200 squared minus 3,14 into 200 cubed. Your answer to this, I think it's 125600000 units cubed. That's your final answer. So you take your final answer, you plug it in, and that would give you your final result. Boys and girls, we're taking an ad break. When we get back, we're going to continue with optimization.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back to the K-Way Math Show. We are busy with optimization. Now, here's a second problem. We're going to do another 1 or 2 more examples just to get you working with optimization in calculus. So now they give you a shape that looks like this. You can take the shape down. They give you a big square and they give you an inscribed square within the bigger square. The question says find the area of the shaded part in terms of x. Question number 2, find x giving maximum area. And question number 3, find the maximum area of the shaded part. Now what did I tell you guys when we deal with optimization? The first one, standard formula. Second one, derivative. Last one, substitution. It's generally always done in these 3 steps. Standard form, derivative, substitution. Standard form, derivative, substitution. So let's put it into standard form. Now we need of the inscribed, we need this. So we need length, we need breadth, in terms of x and in terms of, they're giving us this one whole side to be 200, right? It's a big square. They're telling us it's a square. So if that is 200, that is 200. The whole side here is 200. This whole side here is 200. Okay. Now, if the entire side, let's call this A, B, C, D. Now we know AB is equal to BC is equal to CD is equal to AD. Now, what do we have here? We've got this small piece here to be X. We've got the entire side to be 200. Therefore, the small piece here, let's call it A, B, C, D, E, F, G, H. So, if EB is X and CB is 200, therefore EC, the smaller piece here, will be 200, the entire length, minus X. And we know this piece is equal to that piece, so that is X. Now, we know that this is a triangle, a 90-degree triangle. So let's highlight that piece. That is a 90-degree triangle. So I've got the one side, I've got the other side. I need the length of the inscribed square. So obviously we're going to be using Pythagoras. So obviously to answer question number 1, we know FC is equal to X. FC is equal to X. We know EC is 200 minus X. We know that EC is equal to 200 minus X. Therefore, we now need to find EF, one side. Because if I find the one side, I found all the sides. So now we now need to find EF. And we're now going to be using Pythagoras. Right. So EF squared is equal to X squared. The square on the hypotenuse is equal to the sum of the other two squares on the other two sides. So what do we have? We got EF squared is equal to X squared plus, we're squaring a binomial here, so 200 squared is 40,000 minus, multiply these two and times it by 2, minus 200 times 2 minus 400x plus X squared. So what am I left with? EF squared is equal to X squared plus X squared is 2X squared minus 400X plus 40,000 units, right? That's EF squared. So EF on its own, EF is equal to the square root of 2X squared minus 400X plus 40,000. Now, that is just the length of the side. So that means this here is the square root of 2x squared minus 400x plus 40,000. There we go. That's the length. Now we know that it's a square, so all four sides will equal to exactly the same. So therefore area is equal to length times breadth, which is equal to this times itself, which is exactly, so basically it's this squared. Area is equal to the square root of 2x squared minus 400x plus 40,000 squared. Length times breadth, which is exactly 2x squared minus 400x plus 40,000 units square. And there we go. That is the area of the shaded part in terms of x. Question number 2, find x giving maximum. So that's why we're going to be using derivative. So area is equal to, let's write it down, 2x squared minus 400x plus 40,000. Therefore, derivative dA over dx is going to equal to 2 times 2, that will give me 4x minus 400. 4x minus 400, what do we know for minimum or maximum? For minimum or maximum, derivative must always equal to 0. Is equal to 0, 4x is equal to 400, x is equal to 400 divided by 4, x is equal to 100. And there we go, we've answered question number 2, find x giving maximum area, x is equal to 100. Obviously, find the maximum area of the shaded part. So all you're going to do now for number 3, you're going to say area is equal to 2 into 100 squared minus 400 into 100 plus 40,000. So what do we have? 100 squared is 10,000. 10,000 times 2 is 20,000. So we've got 20,000 minus, that will give me 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 plus 40,000. So what do we have? Minus 40,000 plus 40,000 will cancel out. We're left with 20,000 units squared. And that is the area of the shaded part in terms of x. So this was example number 2. We're now going to go on to one more example, boys and girls. One more example before we wrap up with optimization. Now, you can use these principles to apply it. Obviously, the shapes are dynamic. Every time you get into the exam, they're going to give you new shapes. They're going to give you something that you haven't seen before. But you need to be working with your past papers. At least you know you are working with it. You know what's happening in the question. Right? So this is what optimization is all about. Can I erase? Let's move. I'm going to give you one more where they give you a graph. Okay, many of you have seen this before. Very popular question that has appeared in many past papers before. Okay, so they give you that, they give you this, they give you a parabola. They tell you that f of x, this is graph f, they tell you f of x is equal to minus x squared plus 9. They give you the equation of f. Now remember, this is calculus, this is not functions. Now they give you a rectangle inside there, okay? And they tell you, they give you this, and they say, find, question number one, find, and they call this x. They tell you that this piece here is equal to that piece, and that piece is called x. Okay, find the area of the shaded part in terms of x. That's the first question. Number 2, find x giving maximum area. Okay? Those are the 2 questions that is asked. Probably the first one here worth about 3 to 4 marks. The next question, another 3 to 4 marks, 8 marks on that one question. So take it down. Now we need to look at the shape. We know if this is x, this is x. And we know this is a rectangle. So that means the length of this entire side here will be 2x. So if this is 2x, we know that is 2x. We know we need the area. And what do we need? Length times breadth. So we've got the length. We are short of the breadth, because once I got the length and I got the breadth, I can then find the area of the shape. Okay, what are we going to do now? We've got a couple of minutes now. I want you now to process what is happening. You are given the equation. You are given the equation of the parabola. You're given an inscribed rectangle within, underneath the parabola. You need now to find the area of that. So all we are short of now, we are short of the breadth. We are short of one side. Okay, we're going to be taking a quick ad break. When we get back from the break, you've got 3 minutes now to try and identify, try and analyze and process what's happening there on the screen. When we get back from the break, we're going to then work out the memo. Let's see how well you do. Enjoy your break.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back from the ad break. We cut off before the ad break, giving you a problem here to do under optimization in calculus. Right, so we gave you a graph here. We told you here's a parabola given by that equation. We gave you rectangle underneath it, and we said find the area of the shaded part in terms of x. Now, obviously, guys, if you know that the distance from here to here is x, therefore this one's distance here would also be x, because this is 90 degrees. So if this is x, whatever the x value is, that will be x. What is its y value? What is the y value? If x is given, what is its y value? Its y value is f of x, obviously, because we know from functions, if we got x, a y value is f of x. So if this is x, its y value is f of x. But isn't f of x given? F of x is given already. What is f of x? Minus x squared plus 9. So there's my x value, right? So this is my length, 2x. What is my height here? What is my y value here? If this is my x, I'm only interested in the y value. What is the y value? The y value in terms of x is minus x squared plus 9. So that's your x value, x, and your y value is negative, because we know that this is the y value of your graph at that point. So let's go. to answer question number one, we're going to say area is equal to length times breadth. What is your length? X plus x. Remember, although this is a negative x value, distance can never be negative, so we ignore the negative. X plus another x, we get 2x. What is your breadth? Minus x squared plus 9. So this is equal to, we can multiply this out, we get minus 2x cubed plus 18x. And that is your area of the shaded part in terms of x. Let's answer question number 2. Find x giving maximum area. So now we're going to use derivative. So we got area is equal to minus 2x cubed plus 18x. Therefore, dA over dx is equal to minus 6x squared plus 18. Now we know for minimum or maximum area, it must equal to 0. Just put that better. So we've got minus 6x squared is equal to negative 18. Negative and negative will cancel. X squared is equal to 18 over 6. X squared is equal to 3. X is equal to plus or minus the square root of 3. So that would be plus square root of 3. That would be plus square root of 3. That would be negative square root of 3. There we go. Find x giving maximum area. X is equal to plus or minus the square root of 3. If they say now, find the maximum area of the shape, obviously you just take your square root 3, plug it back into your original and get your maximum area of your shape. Okay, so boys and girls, that brings us to the end of optimization. That brings us to the end of calculus. We've covered the entire calculus, hopefully as thoroughly as possible. Like I said, boys and girls, if you guys do need bigger input, you need more information on our series or on our program, please ensure that you purchase our set. Our email address is on the it's on the screen. Our contact details are there. We're here to serve you, the community. So anytime you need anything, please contact us at kwaymath@gmail.com. Our cell phone numbers are on there, or contact the TV station. We are here for you, the viewer. Boys and girls, we love your feedback. We love your comments. Contact the station. We'd like you to be part of the show as well. So let's hope that at the end of Ramadan, after Ramadan, we're going to be having an ongoing show, the Kway Math Show. And inshallah, we'll be doing physical science and chemistry as well for the grade 11s and 12s, showing you shortcuts, showing you better ways. We have summarized the entire organic chemistry on one page. So stay tuned, stay focused, and keep on watching the Kway Show with me, your host, Muhammad Kota. Assalamu alaikum wa rahmatullahi wa barakatuh.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا مغاربها.